Okay, so I've got a problem. So sorry, we're looking at mixed exercise 6 from the first year core textbook on circles, and we're onto a problem solving one. So I think this one might be relatively tricky. So right, so let's start sketching out what they describe to us. Okay, so we have a circle. We have got, that's one of my better circles, right? So we've got the center at 2, -1. AB is a chord, so let's get the roughly scale. So 3, 7 can be about there, and -5, 3 is going to be to the left and up, so about there. So not drawn to scale, but I'm just getting them in roughly the right positions. And then AC is a diameter, so that is going to put C down there somewhere. So I'll just move that a little bit out of the way. So that was 2 -1. Okay, and so AC is a diameter, so that's obviously going through the center. And we want the area of triangle ABC. Okay, so first thing I can spot is thinking about your circle theorems from GCSE, because there's a few of them that we still need to use in some of these circle problems. If you make a triangle using the diameter, and then you put a point on the circumference of the circle, that will be a right angle triangle. So if I know that that's a right angle, if I can get that length there and that length there, they are the base and the height of my triangle, so I can then do half base times height. I can get both of those if I can find C. So I think this question comes down to, can I find the coordinates of C? So, and hopefully the answer to that is yes. We shall find out. Okay, so what do I know about C? Well, I know it's, I think my best bet is going to be to think about this diameter here, because obviously I know that C lies on the straight line that goes through A in the center. So in fact, let's figure out the equation of the diameter, of that diameter. So let's figure out the equation of the line which goes through A and C. Okay, so because also I don't have C, but I do have 2 coordinates that it goes through. So if I use those, so the gradient of that line, change in y, so 7 minus -1 over 3 minus 2, so that's 8 over 1, so that's 8, so I've got the gradient of it. If I then use y minus y1 is m times x minus x1, and I'll use coordinate A just because it hasn't got any negatives. So y minus 7 is the gradient times x minus 3. So y minus 7 is 8x minus 24. So y is 8x. What am I doing? Am I doing that one? Minus 17. Okay, so that's the equation. So that is the equation of that line. Okay, so I know C lies on that line, but there's lots of points that lie on that line, so I need further information. Well, the other thing I know is that obviously that's the midpoint, so I know that they are the same distance. They are both the radius of the circle. So let's get the radius of the circle. So the radius is obviously just going to be the distance from 2 minus 1 to 3, 7. So that is going to be the square root of 3 minus 2 all squared plus 7 minus -1 all squared. So that is going to be, let's do that to my calculator, so that is going to be root 65, I think, isn't it? 1 plus 64. Okay, so that's root 65. So I also therefore know that the distance between I thought it was a highlighter, but the distance between 2 minus 1 and C is root 65. So if I start to use that, I think I'm going to end up with some simultaneous equations that I can solve. Let's try and keep that on the same page. So then I can also say, so let's call C, I don't know what happened there. We've already used A, B, and C. So let's call C M. In fact, let's not use M because we use that for gradient. Let's call C PQ. Okay, so if I do the distance between the midpoint and C, so it's going to be P minus 2 squared plus Q minus 1 squared, and I know that that should equal root 65. So if I square both of those, yeah, okay, I can see an end in sight. It's quite a lot, right? So if I square both sides to start with, just to get rid of that square root. Okay, so I have now got two equations. This one, so I know that PQ, so going back to my straight line one, let's scroll up because I just need those equations now. So obviously I know that PQ lies on that line where X is P and Y is Q. So if I put those in, so Q for Y and P for X, okay, so now I've got two equations just in terms of P and Q. So we can do that. We can solve those simultaneous equations. So by far and away the easiest way to go is going to be to substitute that in for Q. So we're going to end up with a quadratic in P that I'll then be able to solve. And this is the hard bit. Once we've got P and Q, finding the area of the triangle is really straightforward. Okay. Right, so let's let's write it out clearly before I start expanding. So Q is 8P minus 17, and then I've got that plus 1. So if you're happy with that, I'm just going to call that minus 16 just to save writing the whole line out again. Okay, so I'm going to square out all those brackets. So that's going to give me P squared minus 4P plus 4. So then I've got 8P times 8P. I've got 8P times minus 16, and then I've got that twice, so minus 256P, and then I've got minus 16 times minus 16. Okay, so now I've got a quadratic in P. So I've just collected my P squared terms together. Then I've got minus 4P minus 256P, so minus 260P, and then I've got 256 plus 4, so 260, minus 165, so plus 195. That does all cancel, but I'm running out of steam, so I'm just going to put that into the calculator. Okay, so I've got A is 65, B is minus 260, C is 195. Okay, that's giving me integers. They don't have to be integers, but it's always a slight confidence boost when they are. So I'm getting P is 3 and P is 1. Okay, now that's fine. So I was just looking back to the question to figure out how I know which is which. Well, yeah, and this is also a massive confidence boost that we are on the right track. So I'm getting P is 3 and P is 1. Well, all I've defined P as is a point on this line that's root 65, a distance of root 65 from the center. So we were expecting to get 3 as an answer. So that's the x coordinate of 3. So that's the one we already had. So that's the one, that's our missing one. Okay, so that was by far and away the hardest bit. Now we're pretty much there because I can just say, okay, so now I know that P is 1, Q is 8P, so 8 times 1 minus 17. So make sure I don't mess it up at this stage. Yep, that's going to be minus 9. So let's draw the whole thing out again. So I had the diameter, we had the point on the circumference. We'd already said that we know that's a right angle. We've just worked out that this is 1 minus 9. We already had the other two, so 3, 7 and minus 5, 3. They were given to us. What was what? I think that was C, wasn't it? That was A and that was B, not that it really matters. And what we were aiming for was to be able to find that length and that length, which I was calling the base and the height of that right angle triangle. So the end is in sight. So the height is the distance between these two. So 3 minus minus 5 all squared plus 7 minus 3 all squared. So 64 plus 16, so root 80. There's no point simplifying that because I'm just going to substitute it into half base times height shortly. So the base is the distance between, no, ignore that, is the distance between those two. So that is going to be 1 minus minus 5 all squared plus minus 9 minus 3 all squared. So that is going to be 36 plus 144. So that's going to be root 180. So fingers crossed. The area is half times base times height, which is 60. Okay, so quite a tricky one, that one. I don't think there was a quicker way of doing it. There'll certainly be alternatives, but I think, yeah, they did say it was problem solving, to be fair, and it certainly was. Okay.